In section 2, we're going to talk about those angle relationships we discussed at the end of section 1, but more specifically with parallel lines. So the biggest thing to remember here is if two parallel lines are cut by a transversal, then the following relationships hold. So the first one says, by the corresponding angles postulate, each pair of corresponding angles is congruent. So if we have a pair of corresponding angles, then they have the same measure. By the alternate interior angles theorem, each pair of alternate interior angles is also congruent. By the alternate exterior angles theorem, each pair of alternate exterior angles is congruent as well. And then last one says, by the consecutive interior angles theorem, each pair of consecutive interior angles is supplementary. If you remember, supplementary means adds to 180 degrees. So again, all four of these are those relationships we talked about at the end of section 1. So if we have two parallel lines cut by a transversal, then we have corresponding alternate interior and alternate exterior angles all being congruent, and then consecutive interior angles being supplementary. Let's go ahead and use those theorems in the postulate to find measures of angles. So in our figure, the measure of angle 3 is 110 degrees and the measure of angle 12 is 55 degrees. We want to find the measure of each angle. So remember I told you in the last section that these triangles indicate parallel lines. So those are the parallel lines we have. So let's go ahead and indicate the angles we know. Angle 3 is 110 degrees and angle 12 is 55. All right, so let's go ahead and look at angle 1. So angle 1, we want to use which of our angle relationships will help us find the measure of that angle. Well, we're going to want to use these 8 angles to help us find the measure of angle 1, since that's the transversal that intersects the parallel lines. So let's start with the fact that angle 1 is exterior, which means we're either going to use the alternate exterior angles theorem or corresponding angles, since those are the only two that involve exterior angles. But I don't know any of the measures of my other exterior angles, so I can't use alternate exterior, which leaves me with corresponding. And luckily, angle 1 and angle 3 are corresponding angles. They're in the same place, but on different lines, so they are congruent, which means angle 1 is going to be 110 degrees. Next, let's take a look at angle 6. So angle 6 is an interior angle, so that means we're going to use corresponding angles, alternate interior angles, or consecutive interior angles. Well, in order to use consecutive interior angles, I'd have to know the measure of angle 7, which I don't, so we're not going to use that. In order to use corresponding angles, I'd have to know the measure of angle 8, which I don't, which leaves us with alternate interior angles. And the alternate interior angle to 6 is 3, which again we were given, so we know angle 6 and angle 3 are congruent, which have a measure, so angle 6 also has a measure of 110 degrees. Next, we want to look at angle 2. So again, angle 2 is interior. We know angle 3, and they are consecutive interior angles, which means they're going to add to 180. So we know the measure of angle 2 plus the 110 degrees we have for angle 3 is going to equal 180. So to solve for the measure of angle 2, we're going to subtract 110. So we get that angle 2 has a measure of 70 degrees. Now we're going to move to our other set of angles cut by a transversal. So that would be these 8 angles. The first angle we want to look at is angle 10. which is an interior angle. And using the angle we're given, angle 12, they are corresponding angles, which means they are congruent, so angle 10 has a measure of 55 degrees. Next, we're going to look at angle 13, which is an exterior angle, and it is an alternate exterior angle to angle 12, which means they are congruent, which means angle 13 is also 55 degrees. And lastly, we want to take a look at angle 15, which doesn't actually have a direct relationship to angle 12, not that we've talked about in this section, but it does have a relationship with angle 13. So angle 15 and angle 13 are corresponding, which means they are congruent, which means angle 15 and angle 13 have the same measure. So it is 55 degrees since angle 13 was congruent to angle 12. So all three of those angles have a measure of 55 degrees. You could have also used the fact that angle 15 and angle 10 are alternate interior angles, so they are also congruent, which would have also given us another reason to know that angle 15 has a measure of 55 degrees. So we want to find the values of x and y in our figure. We are given two parallel lines cut by a transversal. So we have to determine which variable to solve for first. And based on where our angles are located, y is going to be the variable we want to solve for first, because the angles that were given that involve y are going to be consecutive interior angles. They're on the same side of the transversal and they're interior. So I know that when I add those two angles together, we're going to get 180. So 8y plus 2 plus the 25y minus 20 is going to equal 180 degrees. Combining like terms on the left, 8 plus 25 is going to give us 33. So 33y, 2 minus 20 is negative 18, equals 180. Next, we're going to add 18 to both sides. So we get 33y equals 198. Lastly, we're going to divide by 33. And we're going to get that y equals 6. That's the first part of our problem. Now we want to solve for x. So we want to use the fact that our angle involving x is alternate interior to our angle with the 25y minus 20, which means they are congruent. So I know 10x has to equal 25y minus 20. So we have, over here, we have 10x equals 25y minus 20. And now that we have a value for y, I can plug that in. So we get 10x equals 25 times 6 minus 20. So we get 10x equals 25 times 6 is 150 minus 20. So 10x equals, and then 150 minus 20 is 130. Divide by 10, and x equals 13. So we've solved for x and y. And now that we have x and y, we can also find the measures of the angles in our figure if we wanted. So next we want to find x and y in our new figure, which this is a trapezoid. And we have two sides that are parallel, and if we want to, we can actually extend our transversals and our sides so it looks more like a picture we're used to help us identify what angle relationships we have. So it makes it a little bit easier to see what we have this way. So in this case, it actually doesn't matter which variable we solve for first. We have enough information that we could solve for x first or y. Y is actually going to be a little bit easier to solve for, only because it's a little bit fewer steps. So if I look at my angle involving y and its transversal, so these set of angles, my 90-degree angle and 3y plus 18 are consecutive interior, which means they're going to add to 180. So we have 3y plus 18 plus 90 is going to equal 180. So combining like terms, we have 3y plus 18 plus 90 is 108 equals 180. Subtract 108 from both sides. We get that 3y equals 72, and then divide by 3. We get y equals 24. Now we want to solve for x using its transversal. So again, 15x plus 30 and 10x are consecutive interior angles, which means they are also supplementary. So we know 15x plus 30 plus 10x is going to equal 180. So combining like terms, we get 25x plus 30 is going to equal 180. Subtract 30, we get 25x equals 150. And then lastly, 150 divided by 25. And we get x equals 6. And once we know x and y, we could find the measure of the angles if we chose to, and you're more than welcome to if you want. So in this last example, we want to find the measure of angle 1, which does look a little bit more difficult than our previous two examples because our transversals aren't as obvious. We have our two parallel lines, but then we have our two lines between those. So what I'm going to actually do first is extend our transversals so we have a better idea of what we have for an image. And the first thing I actually notice is that my angle 1 and my angle right here form a linear pair, which means they sum to 180 degrees. So if I can find the measure of this angle, I can use that to help me find the measure of angle 1. So what I'm going to use is alternate interior angles. So I know that my angle up top of my transversal created with a 31-degree angle is alternate interior with my 31-degree angle, means they are going to be congruent, which means this angle is also 31 degrees. And I also notice that this parallel line, once I extend my transversals, it creates a triangle. And if you remember, the measure of the interior angles of a triangle is 180 degrees. So I can use that to find the measure of this angle, which I'm going to call x. So we know 31 plus 36 plus x is going to equal 180 degrees. So when I combine my like terms, we're going to get 67 plus x is going to equal 180. We're going to subtract 67. And we're going to get x is 113. Now that I know x, and I know it's a linear pair with angle 1, we know the measure of angle 1 plus the 113 is going to equal 180. So now to solve for the measure of angle 1, I'm going to subtract the 113. So we get that the measure of angle 1 equals 67 degrees. So in this last example, we're going to answer two questions using the picture over here on the right. And in number 1, we want to determine whether angle 1 is always, sometimes, or never congruent to angle 2. So angle 1 and angle 2 are right next to each other on the same line. And for those two angles to always be congruent, if we remember our three angle relationships that are congruent, they'd have to be corresponding alternate interior or alternate exterior angles, which they are not. So they are not always congruent. But angle 1 and angle 2 do form a linear pair, which means they sum to 180. And there is a chance that they could both be 90-degree angles, in which case, because since 90 plus 90 is 180. So they could sometimes be congruent. So I'm going to say sometimes. I'm going to say because the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So if measure of angle 1 equaled the measure of angle 2 equaled 90 degrees, then they would be congruent. Now, so in the second question, we want to determine the minimum number of angle measures you would have to know to find the measures of all angles in the figure. Then we want to explain our reasoning. Let's identify some angles that are congruent to one another using the relationships we talked about to help us figure out how many of the angles we have to know. So let's start with angle 1. So angle 1 is corresponding to angle 5, which means they are congruent. It is also alternate exterior to angle 7, which means they are congruent. Then we want to move to angle 2, which is corresponding with angle 6, which means they are congruent, and it's alternate exterior with angle 8, which means they are congruent. That just leaves us angle 3 and 4. Well, angle 3 is alternate interior with angle 5, which means they are congruent, which also means it's congruent to angles 1 and 7, and then angle 4 is alternate interior with angle 6, which means they're congruent, and it's also congruent to angles 2 and 8. So it looks like half our angles are congruent to one another. We also, as we already discussed, angle 1 and angle 2 are a linear pair, which means they add to 180 degrees. So the minimum number of angle measures I have to know is one angle. So I need to know one angle. Because if I say I know angle 4, I know the measures of angles 2, 6, and 8. I can also use consecutive interior angles to help me find the measure of angle 5, in which case I would then know the measure of angles 1, 3, and 7. And you can write that all if you would like. It's going to be a bit of a lengthy explanation, but it just boils down to the fact that half the angles are congruent to one another. So if you know just one of them, you can use that information to help us solve for the other 7. So hopefully this gave you a little bit of information about how we can use angle relationships and parallel lines cut by a transversal.